Okay, let's wait for a few minutes for other people to join. Is the slide visible to you, um, Devapriya? No. Devapriya, am I audible to you?
Yes, sir.
Okay. And slide is also visible?
Yes, sir. Yes,
Okay.
sir.
So have you attended the lectures, week 7 lecture on the portal, Swam portal?
No, sir. Sixth. This is first time, sir.
Okay. So till sixth week you have attended.
Yes, sir. Yes, sir. Sixth week.
Okay, let's do the problems. So this is the first equation. You are attending the problem solving session for the first time.
Yes, sir.
Okay. So we can go in this manner. I will show you some problems, and you try to solve them. Then we will discuss.
Okay, sir.
Okay. So this is the first problem. You can
Okay.
work out the solution. Then we will. So the first problem says, which of the following are the disadvantages of disposing of contaminated soil and land? So in landfill, we can dispose of both hazardous and municipal solid waste. The question is asking what are the disadvantages if we directly dispose the contaminated soil into landfill. So it's an easy question. You try to answer it. We will discuss it.
Sir,
Yeah.
option A, sir.
Option A is leachate and landfill may contaminate soil
Contaminate.
and groundwater. Okay, that is true. Uh, Specific option is true.
Okay, sir.
Leachate, because if you put contaminated soil, there will be generation of leachate based on how well. how much moisture is present and how much moisture is coming from the rainfall, how much water is coming from the rainfall. So if you have a landfill, so what do you think about second and third option?
Transport. It is not talking about environmental pollution. High excavation and transportation costs. Uh, Actually, option A, it is talking about environmental pollution, no, sir.
Yeah.
Um, can you just explain that, sir?
Okay.
High
Okay.
excavation and
So high excavation means if we are like landfill will be normally landfills are constructed outside of the city, right?
yes, sir.
Near the boundary of the city, normally outside, like far away from the city area where it is populated because of the various issues like gas and smell and all those things. You know? So, so we are not sure that the contaminated site is near landfill only. It can be anywhere, right? So you have
Yes.
to carry that soil to that particular landfill. So there will be huge uh, cost involved of transportation as well as you have to excavate the soil. You have to take out the soil from a particular area which is contaminated, and then you have to transport it to the landfill. So there will be some cost in that also. So is it an advantage or disadvantage?
Um, Disadvantage, sir.
Okay, as compared to other methods like you might have uh, already studied like PRB, permeable reactive barrier, and all those methods, right?
Yes, sir.
Where PRB actually won't treat the soil, it treats the water, but as the concentration reduces, the contaminant will come out of the like get dissolved in the soil, right? As the concentration reduces in the water, it will try to again make an equilibrium by coming into the water, right? Based
Yes.
on what is the nature of the contaminant. So your first response is correct. Leachate and landfill may contaminate soil and groundwater because if
Yes.
there is leachate generation, we have to make sure that that leachate gets treated as well as it doesn't reach the groundwater, right?
Yes,
So
sir.
that is an issue. Second, high excavation and transportation cost is also an issue. And what do you think about limitation of space?
Limitations of space.
Like in general, when we see landfill is basically disposal. Okay. And if in the modern approach, like earlier disposal was mostly one of the only options which how we dealt with the solid waste and hazardous waste and all those things. In India today also most of the waste goes into landfill only. But before landfill, we try to minimize the amount of waste that is going to landfill. Right? So for that we use different things like if we consider solid waste, we will try to extract from organic matter. We will try to extract energy, or we will try to convert it into fertilizer using different methods like anaerobic digester, and we'll prepare compost and all those things, right? And our other than in inorganic waste, we will like if it's paper waste, if incineration, the calorific value of the waste is high, we will try to burn it in incinerator and extract some energy. And at the end, we will try to minimize the waste which is going to landfill, so that that landfill stays for a longer period of time, right?
Yes.
So we try to minimize the amount of waste which is going to landfill to sort of create a circular economy. Sort of thing. We can waste to energy. We can extract a lot of energy as well as other resources from the waste, and then whatever left after that which we can't decompose or we can't use, we dump it into land. So in case of soil, contaminated soil, like, can we extract something from contaminated soil? Does it have high calorific value, or is it a organic matter which we can extract some gas or fertilize, compost or something? No, right?
Yes, sir.
So it will unnecessarily create a lot of volume which is going to landfill. So what do you think? Is it a disadvantage?
Um, yes, sir.
Yeah, it will be a disadvantage because it will unnecessarily occupy a lot of space in landfill, right?
Yes, sir.
So we don't want that. So all these three options are correct. Leachate from landfill may contaminate soil and groundwater. If there is some leakage, if the leachate comes out of uh, the protective layers or detection systems we have put, like SDP and consolidated clay, different layers we put
Mhm.
before putting waste into the landfill. So if get breached, then the leachate comes out of the system. Then it can contaminate the soil around and the groundwater. So for that, first option is correct. And high excavation transportation costs we have discussed, and limitation of space. So all three are correct. So correct answer is all of them.
Okay, sir.
This is the next problem. Are you guys aware of leakage detection system, LDS, in landfills?
Yes, sir.
Are you guys aware of this leakage detection system? Like in whenever we create landfills, so we put some geo geotextiles, geomembranes, and clay layers, and all those things below the landfill, so that leachate doesn't get through this. So those things we call, there is a specific layer where which is put in these layers, which is called as leak detection system. So have you studied about this or
No, sir, no idea.
okay? So basically there are two classifications. First is like landfill we make for the disposal of municipal solid waste. Municipal solid waste. And then hazardous waste. So for hazardous waste, those landfills are called as TSDS, treatment disposal, treatment soil disposal facility. So we'll sort of draw the stratification of those landfills. Like what are the layers which we put in case of municipal solid waste and hazardous waste. So in case of MSW, there are like single composite liners and double liners. So we will see what are those basically. So here this is our normal soil surface, subsurface soil, right? Then if like this is the ground level and digged we are digging up to some depth. So this is the lowest level which we are digging up to. So this is the subsurface soil. Above that, we will put a clay layer of clay. So this is the like a clay layer which is around depth of 2 feet. Uh, can you guess like why we are using clay as as one of the layers?
Why? Because it should not get into the soil. The
Uh,
other.
in the subsurface soil.
Ah, yes, sir.
So why we are using clay only? Can we use any other soil?
No, sir, we cannot.
So like we have different soils like uh, silt, clay, and normal soil and like gravels. So there's a difference in the permeability in all these four classifications, right?
Yes, sir.
So the permeability for the clay soil is least. It is like less than equal to 10 to the power minus 7 centimeter per second. There are like two terms like porosity and permeability. Porosity for clay soil is high. There are many voids. Porosity, porosity. Do you understand the term porosity? Porosity is actually uh, basically the volume of voids divided by total volume. So, like if we consider these as soil particles, So if this is soil particles and this is the total volume.
Okay.
And if you put water into it, it will contain some water, right?
Yes, sir.
So water will get displaced into these spaces.
Yes. If it is normal soil, it will get, I mean, the water will get
In
inside.
case of clay also it will get,
Oh, oh, okay.
in case of gravel also. But the issue is these spaces are called the voids. So porosity is your volume of voids divided by total volume. Total volume means this volume of this container. And permeability is how effortlessly this if we put water, it is moving through the soil medium. We can also see from the unit also how much distance is traveling per second. So permeability for the clay soil is 10 to the power minus 7, and I think for if you for sand it is around 10 to the power minus 3. I think 10 to the power minus 3 or minus 1. I'm not sure. And for silt it is around 10 to the power minus 3. I think minus 3 or minus 5. So what I'm trying to convey is
Minus
the
3 or
permeability uh, for the sand, and sand is very high, and for clay it's very low. If you put if the leachate is here, its ability to travel through the clay layer is very low because these pores are not connected in clay. In sand also has pores, but those pores are sort of connected to each other, so they sort of create a path. But in clay, these voids which are present in particles are not connected, so they don't create a path
space.
for water or anything to travel through. So
Oh,
that's why the clay has the low permeability, and that's why we use clay in as the one of the soil. Yeah. So above this, there will be one more layer of HDPE.
STP.
HDPE is high density polyethylene. Then above the HDPE, you have basically a drainage material like gravel. This layer you have basically drainage material, which will be a sort of a layer between the actual waste and the geomembrane. So if you put gravel here, the leachate will, because it is porous, right? It has very high permeability more than sand. So it will like it will stop the bigger particles, but it will allow the leachate to travel below, right? So this is the certification for the single composite layer, and above here we have waste. But in this stratification, there is no leakage detection system basically, right? Because
Yes.
only once if the leachate is able to move through HDPE, which is the impermeable layer, HDPE, which has very low permeability, uh, almost impermeable. So if it get damaged, the layer gets damaged, it will travel through clay. Clay will be the only membrane only barrier which will be there present, which prevent leachate from going into the subsoil. So there is no detection. We can't detect here. So but for that there is another system called double liner. In double liner system,
3.
So the this is the subsoil, subsurface soil.
Surface.
Above subsurface soil, there is a clay layer, and this is HDPE membrane,
HDP membrane.
and this is your top granular layer, which is basically drainage material. So these components we already have in the single liner, right? Here we discussed these all these material are also available here. But there is some additional materials which are available in the double liner system, which is basically we are talking materials which are basically used for achieving the leakage detection as well as impermeability are geotextiles. So we have various types of geotextiles like geomembrane and we have geonets and all those things. So each has their different abilities. Like for example, we use here SDP, which provides impermeability. So in case of leakage detection, we use another geotextile which is called as geonets.
Okay, sir.
So if for example, here we have waste. So waste is producing leachate, and that leachate is coming through this granular material which is provided. It will prevent waste from coming in contact with the layer, but it will allow the water to flow, the leachate to flow in the downward direction. So if this HDP layer gets harmed or get teared, so the leachate will flow in the downward direction. So it will come in contact with geonet. So what geonet does is it doesn't allow the it basically allows the lateral direction movement of the leachate. So it won't allow the downward movement, but it will allow the lateral direction. It will allow the leachate to move in this direction, right? So if any leachate comes out of the this HDP membrane, then the leachate will move in the lateral direction, and here's it will come out of the landfill. So for example, what I'm trying to say is if this is the landfill, there's always some sort of slope which is provided in landfill. So if this is the layer, if this is the geonet layer, so there will be uh, in between pipes which will carry that leachate outside and into a well. So if there is some leachate collected in this well, which is basically a well which is connected to geonet. Above here also there will be pipes which will be carrying leachate to a well. There the leachate will get treated. But if there is some leachate which is collected into a well which is connected to this geonet membrane, right? Then we can say that there is basically a leakage into HDP, because otherwise there won't be any leachate in this area, right? And uh, consequently there will be no leachate in this particular well which is connected to the geonet map. So if there is any leachate collected in this region, that means there is some problem with the HDP impermeable layer which we have provided. Now after the geonet membrane, there is again an HDP layer. Again, an impermeable layer is provided below,
Gee.
and then there is clay layer. So this is basically a double liner system. This is for municipal solid waste. Then again, we have hazardous waste. So for hazardous waste, there is slight modification. Sir, I have already discussed the basically the stratification in the class, but I will discuss with one like real time. Uh, there's one TSDF I visited, so I sort of have that stratification how they did. So I will discuss that example. That, that as an example. So lowest layer will be again the same, which is then this is subsurface soil. Then this is clay, compact clay. And above this you have HDPE. After that you have a geotextile layer. This is filter media, which is basically gravel layer, and these are pipes. Of this, again there will be a geotextile, and there will be a layer of clay, and HDPE, then you have geotextile. This is again filter media, which is gravel. This you have geotextile again, and then you have your hazardous waste. So this is basically the cross section area of TST. So the first layer, this layer is basically geotextile, right? Geotextile. This is also geotextile. This is also geotextile. Why we didn't put HDP layer here? Otherwise, we are putting one HDP layer everywhere where we are putting geotextile. Hello?
Mm.
Why we didn't put an HDP layer here
Yeah. Why?
below this one?
Waterproof.
Because we want to treat the leachate which is generated, right? So we for creating that leachate we need to collect that leachate. So what is the use of geotextile layer here? This geomembrane.
Sir?
What will be the use of this geomembrane here? Like if we put hazardous waste above gravel, then also leachate will come out here, and it will, like, from here these lateral pipes will take the leachate outside. But why did we put a geomembrane here?
Why? Because it controls that fluid. That is why, sir. That geomembrane.
Okay. Yeah, like
Yes.
yeah, we can say that, but main, like, sort of, if reason, if we think like the soil particles and hazardous waste which is present here, it doesn't clog the this filter media, right? If it is in direct contact, those particles will also come here. The sludge also will come here, and it will clog this filter media. So to prevent that only leachate comes out to the filter media, and the filter media doesn't get clogged because it will be under a lot of waste, right? So we can't just dig again and again and unclog the filter media, right?
Yes, sir.
So so this geomembrane prevents the basically the filter media from clogging and allow the leachate to come here, and which could be collected through these leachate pipes. So these leachate pipes are basically runs into a well, leachate collection well. All these are connected literally, and below this we have one geotextile layer again, right? And then we have an HDP. So this HDP is basically the first protective layer which is preventing this leachate from traveling into lower layers, and we have clay layer after that. If this HDP, if this HDP layer get punctured or cracked from some place, then this leachate will come travel in the downward direction, and it will basically, after some time, after traveling through clay layer, it will come to the second filter media, right?
Yes.
If the leachate comes into second filter media, and this second filter media is also connected, these pipes in second this second filter media are also connected to a well. So there also, if leachate show up in the second well or secondary well, then that means that leachate is, yeah, this first HDP layer had punctured and the leachate is showing up in the secondary. And after that, there is another HDP layer, geotextile, then HDP, then clay layer again. So this is basically the system for TSDF for maintaining hazardous waste. So now you try to answer these questions.
Both the statements A and B are correct. So
Sorry,
A and B are correct. The statement.
A and B are correct means C. Both statement A and B are correct. So you're saying this option, right?
Yes, sir.
So the first option is the presence of leachate in LDS leakage detection system serves as an alert for the improper functioning of the primary leachate collection system. This is true. Second is the leak detection system only contains an HDP liner to prevent leachate from contaminating the subsurface. Is it true?
Second one is incorrect.
Uh, second one is
The second,
incorrect. Second one is incorrect.
the,
Why?
yes, the clay layer will be there.
Yeah, yeah, because
Yes,
we also have
yes.
clay layer in both the cases because this is HDP, then we have clay layer for hazardous waste also. This is HDP, but we have clay layer, right?
Yes.
So statement A will be statement A is correct, but statement B is incorrect. So this is the third question. Design and construction of landfill are major factors contributing to landfill's failure.
False.
Design and construction of landfill are major factors contributing. So, what do you think? What will be the other? What are the factors which are majorly responsible for landfill's failure?
And that is base failure will be there.
Base failure. Yeah.
Then pull out of liner system.
Hmm.
Then because of the waste pile and sliding
Yeah.
of
Sliding
the,
failure, like shear failure, you're talking about, right?
yes.
So those will come in design and construction only, na? All those
Yes.
things.
Okay, so we can commonly call it like
Yeah.
that only.
So what will be the answer then?
True.
Yeah. True. So this is basically from search slide only. Addition of these two majorly responsible for landfill. Mhm. Right?
Okay.
This is the next question. With respect to design consideration of landfill stability, consider the following statement. An earthen berm can be constructed at the base of landfill slope to provide resistance to lateral slope movement. Next is it's important to consider the effectiveness of the drainage layer above the cover system geomembrane to prevent rainfall or seepage induced cover system failure. What do you think the answer is for this question?
I think A is correct, sir.
A is correct, right? A
Yes.
is correct. Uh, And what about the second? Like for example, if we have this as the landfill, this is the waste fill here, and above that we provide impermeable layer, and then we provide soil, and then we plant something normally. So why are we providing this layer, this impermeable layer above waste? What do you think? What is the main reason for leachate generation?
Due to compaction,
For leachate generation? In
or
leachate, like if we extract all the water from the waste we are putting here,
okay. Then
so this,
rainfall. Uh,
yeah, then there will be no leachate, right?
yes.
But because of the moisture in this waste, and the rain, because of the rainfall, some water gets into the system from the
Yes.
above or from the later direction maybe. Because of that, there is more water, and then that water increase then basically generates the leachate, and there is some in reactions also anaerobic digestion. Because there is anaerobic digestion, there is acid generation, and which reacts with other compounds present. But if there is no water, then there won't be leachate, right?
Yes, sir.
So to basically be sort of along the same lines, it's important to consider the effectiveness of drainage layer. So this drainage layer. So more effective, more impermeable this layer is, or it is well designed, then there will be no water, no rainfall water which will be entering the system, right?
Yes, sir.
Power system, prevent. So what do you think? Both are correct.
Yes, sir.
But fifth question. The geotextile layer should be provided above the leachate collection system. Is to this we have already discussed in previous question.
Yes.
Yeah. What do you think? What will be the answer?
Um, to prevent infiltration of rainwater.
Geotextile layer. mm, that is geomembrane for water. We sort of provide an impermeable layer above. Normally, like for example, it is right. Mm, Textile. This is geotextile. This is geotextile. So why we are providing geotextile here at this location?
To prevent
What? Okay. So what was this layer for?
to prevent uh, leach, lateral movement of
Basically to prevent these fine particles to entering, or small particles to entering this filter media, so that it doesn't clog the filter media. So if we consider that, then what do you think? What will be the answer in this? Like prevent
prevent
infiltration.
entry. Then the third option.
Third option, prevent the entry of fine particles into it. Which- Is this question visible, or do you want me to make it like in presentation mode? Is it visible now?
Yes.
Yes, sir.
Yeah.
Not able to judge, sir. Could you explain that diagram, sir?
Mm. So basically, different types of failure which could, like the landfill which we have drawn, like there could be failure in the landfill itself, right? We are providing some sort, or there could be the waste which we are piling inside the landfill.
Yes.
So those different types of failure they have shown. So there could be base failure, like this this will be act as the rotation radius. This whole soil mass get will displace from its position. Or there could be the failure of the waste which is present inside the landfill. So these two basically are representing the failure of the within the waste, and these two basically representing the failure of the like soil around it. So there will be a, this basically shows the foundation failure. So you have to select from these two, these four which two are correctly matched. Just like try to read this and then see where the failure is shown.
Yeah, the failure is not shown along the liner.
Based on that, what do you think which option will be correct?
Fourth one, sir.
That is not correct. A and D will be the correct answer.
Then
Basically,
B will be the correct one.
B A and B are correctly matched. A and D, sorry, A and D. These two are not correctly matched. This is the next problem. This is basically a numerical which is also discussed in similar type of numerical was discussed in week 7. So uh, like if you have attended week 7, like try it on your own, then we will discuss the solution.
So can you share the formula for us?
So basically, flux calculation, the movement of basically contaminants happening through two ways: advection and diffusion. So there will be flux calculation for both. So in advection, flux is basically the Darcy's velocity into the concentration of contaminant, and Darcy's velocity is basically equal to discharge by area. So this uh, is Darcy's velocity the actual velocity?
No, sir.
So, actual velocity is basically seepage velocity.
Page velocity.
Seepage and Darcy's velocity we can also write as the hydraulic conductivity into gradient. And Darcy's velocity is equal to your porosity into seepage velocity. Because here we assume that if this is the total soil mass, we consider a complete area. But water is not passing through the complete area. Water is passing through the pores. So consider only area of pores. You have to consider only the area of pores. For that consideration, seepage velocity calculation, we have to multiply the velocity into seepage velocity to get the Darcy's velocity. Or if you divide seepage velocity with porosity, you will get seepage velocity. So for advection, flux calculation will be through this formula, and that's how you can calculate the Darcy's velocity, hydraulic conductivity into gradient. Then for fusion, diffusion or dispersion, there will be one more formula which will be velocity into flux through force. And this JP calculation will be fusion coefficient and into concentration gradient. And this diffusion coefficient is equal to this is tortuosity. greater the higher the value of viscosity and how it impact the mass flow. Basically, if if the tortuosity value increases, then mass flow through the media decreases or increases.
Increases.
Mm, I think it's actually decreases. If we have high uh, tortuosity value, then the mass transfer or mass movement through the media actually decreases.
Okay.
The This is the formulas which you will require for the calculation of flux for diffusion as well as advection. So this is the data given basically. Based on that data you can find. First it is asked flux due to diffusion. You write these values, and if you want to see the formula, then you can tell me to like change the slide, then I will.
Sir, is it 0.345?
0.3 to 4. This is Devapriya, do you have one answer? Actually, the value which I have is around point, I think 4 point something or point 0.4 something. Let me solve. So we need to calculate
Okay, sir.
flux due to diffusion, right? So
Yes.
flux due to diffusion will be the velocity into t value into the c over times 0.35. Then d value we have diffusivity is 8.9 divided by 2.01. Then we have delta c by delta. So what value did you take for delta c by delta x?
260 milligram per.
This we can take as concentration gradient, right? So it will be 260. Now the value is in milligram
Milligram per liter per meter.
milliliter. So what is the unit of flux?
Micrograms per meter square.
Like micrograms mass per unit. Like what is the like here it is given, right? Microgram per
Yes.
meter square per second. So basically we can say it as mass per unit area per unit
Time.
time.
That.
So you did this only, right?
Yes, sir.
You were not getting the answer. Huh?
No, yes.
Mhm. 0.35, 8.9. If we solve this, it's coming around 402.935 into 10 to the power minus 8. Value will be here we have meter square, but here we have liter, right? So liter, if we convert in meter, it will be around 10 to the power minus 3 here in denominator. 1000 liters is around 1 meter cube, right?
Yes, sir.
So it will be 1 liter meter cube, so it will be around minus 5, right?
Yes.
Minus 5, but this value will be in milligrams. This milligram we have to convert it to microgram. So milligram to microgram again we have to 10 to the power minus 3 and 1000 multiply divide. So this value will basically will become 10 to the power minus 2, and then 10 to the power minus 2 1 0 will we can shift the decimal, so it will be
Yes.
around
It is
4.02.
0.02.
Okay.
Okay.
Next problem I think we have to calculate the
Be due to advection.
advection here. This already formula we know. Darcy's
Yes.
concentration.
Sir, here velocity is not given, sir. So,
Darcy's velocity actually you can calculate by this formula also. Darcy velocity is equal to hydraulic conductivity into gradient.
okay, sir.
You got the answer?
Um, yes, sir. Conversion.
Yeah, this centimeter meter conversion you have to do.
See, but, micrograms per meter square. I'm not getting, sir.
Okay, no issue.
Okay, 1.90.
What is the value you're getting?
1.92 into 10 power minus 6.
1.92
Yes.
into 10 to the power minus 6.
Yes.
Okay. What is the unit you are getting? Milligram?
It's, actually grams.
Okay, no problem. There will be velocity into concentration, no? So it will be around 6.4 into 10 to the power minus 6 centimeter per second
Mm, no, actually, I
into
have done one mistake, sir.
okay,
Please.
no, milligram per liter. Liter we have to convert into meter cube with 10 to the power minus 3 meter cube. So here we have centimeter, right?
Yes.
Centimeter also, that also if you convert it will be 10 to the power minus 2
Understood.
meter. So this and here it will be become 5 and into 120. So this value will come out to be 768. 768 into 10 to the power minus 5. And this will also cancel out to become meters square, right? So 768 into 10 to the power minus 5 in terms of milligram per meter square
Second.
and seconds. Milligram to microgram 10, it will require 10 to the power minus 3, right?
Yes, sir.
So we can take it from here and other two negative zeros which will be left will put a decimal here, right?
Hmm.
So it will become 7.68 microgram
Micrograms.
per meter square second. Okay, do you have any issue in whatever problems we discussed today?
No, sir.
Mm, mm, all the questions are clear. This is also clear, no?
Oh, yes, sir.
Because in notes, sir have explained, like I think there are around five types of failures.
Oh,
Um,
yes, sir.
so there's along the transitional, this there will be like there will be failure like this along the line in case of in this case, sorry,
Okay.
along this line and there will be some transitional movement. If you want, I can explain. Otherwise, if it's clear, we can conclude.
Okay. Sir, actually, B and D, what type of failure the diagram is shown?
Uh, It's actually the type of failure is like it's an actual failure which is shown, but the diagram it is like diagram is not correct only. Like we
Oh,
have
okay.
like five types of failure. These two are correct, and
Okay, sir.
after that for waste we have a failure within waste mass. So within waste mass, if we have certain failure, then it will be like if we have waste mass like here, right?
Mm.
So the within waste mass, it will fail like this, right?
Yeah, okay, sir.
Yeah, the rotational failure, like this failure, rotational failure. Here it will fail within the waste mass. So if we see the option, so B, the diagram should be this. If you
Okay.
read B, the diagram should be this, right?
Okay, sir.
That means like this diagram should be for this,
Mm, mm.
right?
Okay, sir.
And now read C option. Failure was sliding along the landfill liner system. So for this, if we draw a diagram, then it should be something like this. There will be a transitional failure. Like this is the failure plane. This,
Okay.
right? Failure by sliding along the landfill liner system. This is low along the landfill liner system. So
Okay.
if we see like this diagram should be for this.
Okay.
So in that sense.
Okay.
Now is it clear?
Yes, sir.
Okay.
Okay.
Okay, we will
Thank you, sir.
close the class for today.
Okay, sir.
Mm,
Thank you.
mm.